Number 9, find critical points, critical numbers for this function right here. F of x is 2 times x raised to the power of natural log of x. Before we do anything else, let's just note here that the domain of this function is the same as the domain for natural log of x. Here we need natural log of the domain for natural log of x means that we need to have x to be strictly greater than 0. Okay, so we'll probably need that later on. Okay, let's work with this. So in order to find critical values, critical points for this function here, we need to take the derivative, set it equal to 0, or also think about when the derivative is undefined. Okay, how do we find the derivative of something that looks like this? Well, that's probably going to be something that we can do by doing logarithmic differentiation. So right now, this is what we have. So the natural log of f is equal to the natural log of 2 to the x raised to the natural log of x power, but that natural log of x power comes down in front. Okay, so based off of this then, okay, what are we going to have when we take the derivative? When we take the derivative of the left side here, we end up with f prime of x over f of x. And when we take the derivative of the right here, okay, product rule, so we'll have natural log of x times the derivative of natural log of 2x. So that would be 1 over 2x times, upstairs would be, by the chain rule, the derivative of 2x, which is 2. Plus the natural log of 2x times the derivative of natural log of x, which is 1 over x. Okay, how can we simplify this? Well, those 2's will cancel here. And let's swing f of x over to the other side here. So f prime of x is equal to f of x, which is, recall, 2 times x raised to the power of natural log of x. All of that times this expression right here, which is going to be 1 over x times natural log of x plus natural log of 2x. Okay, so we want to determine when is this equal to 0 or when is this undefined. Okay, first let's just kind of parse this from left to right. So, okay, 2 times x raised to the power natural log of x. When is this 0 or when is this undefined? Well, 2 times x would be equal to 0 when x is equal to 0. But x is equal to 0 is explicitly eliminated from the domain of our original function. I said we'd be using this later because of the natural log of x here. So the only way that this could be 0 is if x equals 0, but that's disallowed from the domain here. And is 2 times x raised to the power natural log of x ever undefined? Yes, it certainly is undefined, but it's undefined at, exactly when the original function itself is undefined. So this doesn't give us any new information. 1 over x. This is undefined if x is equal to 0, but again, that's already ruled out from the domain here. So the only thing we have to worry about is natural log of x plus natural log of 2x. When is this equal to 0? Whereas when is this undefined? Well, this is once again undefined if x is less than or equal to 0, which is ruled out from the domain. So we can conclude that the only thing we care about here is natural log of x plus natural log of 2x equal to 0? Now, logarithm properties say that we can, the sum of two different logarithms equals the logarithm of their product. So this is logarithm of x times 2 times x. All of that is equal to 0. So that is going to be, let's see here, logarithm of 2x squared needs to equal 0. When is the logarithm of something equal to 0? Well, that means that this thing on the inside, 2x squared, must equal 1. And if 2x squared must equal 1, okay, x squared must equal 1/2, or x must equal plus or minus 1 over the square root of 2. And let me write those separately here. Okay, are we done? Did we find two different critical numbers? There's one last thing we have to do here, which is we have to go back to the domain of the original function again. X is equal to negative 1 over square root 2. We might say, oh, look, here we plug it into here. This certainly works. But x is negative here, and we'd be violating the domain here. So this is not allowed, and so here is our only solution.